Is this visible?
Yes, sir.
Yeah. So when we talk about the coordination compound or complex compound, in this metal atom will be linked with the ligands, and ligand could be anion or neutral molecule, correct?
Mm. Mm.
So same complex compound are known as the coordination compound.
Okay.
Example, in case of chlorophyll, we have coordination compound of magnesium. In case of hemoglobin, you already know we have iron,
Mm.
and vitamin B12 contain cobalt. These are the
Mm.
example what we use in the life. Werner theory is extremely important because he was the
Okay.
first person who gave the structure of the coordination compound. Uh, And what actually he did, he characterized large number of coordination compound and studied their physical and chemical behavior
Mm.
by using two valency, primary and secondary valence.
Mm.
What do you mean? Like, what is the difference between these two?
Sir, primary valency is ionizable, secondary is not. And then
Correct.
primary valence gives the oxidation state,
Huh.
and secondary
Primary
valence
valence is usually the oxidation.
oxidation state. Yeah.
Yeah, and secondary valence is based on the number of ligand.
The coordination number. So, what is coordination number here? Uh,
Coordination number is number of ligand,
Okay, okay.
but coordination number also depend upon the denticity. Once you finish denticity, then you find out coordination number.
Yeah, okay.
Example, if you take cobalt,
Mm.
so cobalt can have En 3. It look like coordination number is 3, right?
Yes.
But actually coordination number in this case is 6.
Mm.
How do I know? Because this En have is didentate.
Okay.
That's it. So we can easily explain primary valence based on the like complex number here 3 chlorine, 2 chlorine, or 2 chlorine. We can tell primary valence. For
Okay.
secondary valence, it is important to understand when we precipitate as AgCl. Example, if you have 1 mole of this compound and give 3 mole of this compound, what does it mean?
Mm. 1 mole of CO3. I don't know.
It means cobalt will have 6 ligand in the ammonia form, and all the 3 chlorine will be present outside, and these free 3 chlorine can react with 3 Ag and form 3 AgCl.
Okay.
Understood? But
Yes. Sir.
if chlorine is present inside the square bracket, it means it will never react.
Mm.
Example in the next case. Here you are forming 2 AgCl. It means in this compound, 1 chlorine will be outside and 2 chlorine will be out. Sorry, 2 chlorine will be outside, correct?
Outside.
Because
Mm.
and 1 will
Okay.
be inside. So what will happen in this case? You can draw structure like cobalt, 5 ammonia,
Mm.
and 1 chlorine, and then 2 chlorine outside. Make sense?
Mm. Yes. Sir.
Same way, if you take this, you have 1 AgCl. It means only 1 chlorine outside.
Mm.
Understood?
Yes. Sir.
Why? Because cobalt have coordination number 6.
Mm.
In first case, there is enough number of ammonia, but in second case, ammonia is one less,
Mm.
so chlorine will compensate. In
Mm.
third case, two ammonia are less, so two chlorine will compensate instead of ammonia. But if you see third and fourth case, in both
Mm.
situation, AgCl formed is one, compound is same, but why there is a different color? Here you
Color.
have green and here you have violet.
Not sure.
Because these are isomer, have exactly same formula but different color due to the isomeric nature. They are isomer.
Mm.
Understood?
Yes, sir.
So what is the benefit one what to do this experiment? He got to know in every case there will be six coordination number, correct?
Mm.
And whatever is present inside the bracket will not dissociate into ion,
Mm.
correct?
Mm.
Whatever is present within the square bracket will form a single entity and they does not dissociate under any reaction condition.
Mm.
But outside can form ion, inside cannot. Make sense?
Mm.
And because of that, we got to know about this secondary valence. And what is
Mm.
secondary valence? Number of group that attach to the metal ion. Example, here it is six. Every time it is six. One chlorine, five ammonia, two chlorine, four ammonia. Like all these are secondary valence. Understood?
Mm.
What
Mm.
does it mean? This one designate the square bracket part.
Mm.
Okay. Outside ion represented by this. Got it?
Mm. Okay.
That's why the ratio is this. Same thing is written here. If you see this for ammonia, because there are different property and they are isomer, same formula but different structure. All these 4 points are extremely important. The coordination compounds show two type of valency and linkage. So people will miss this word linkage. They will focus on the valencies. It could be primary and secondary two type. Primary valency is ionizable
Mm.
and will be satisfied only by the negative ion.
Mm.
Secondary valency, non-ionizable. Why?
Inside the bracket.
Exactly. Inside the bracket, that's why. So, and remember, not only neutral molecule, it can be satisfied by the negative ion also. Like chlorine is a negative ion, but
Mm.
ammonia is neutral ion. Both can form secondary valence, correct?
Mm.
And
Mm.
secondary valence is equal to what? Coordination number. And this is fixed for a metal. Like in case of cobalt, every time it is six, right?
Yes.
And whenever there is a secondary valency, secondary linkage, then there will be special arrangement depend upon the coordination number. What is the meaning of special arrangement?
Mm. Yes.
3D arrangement. So now tell me four postulate of Werner's theory.
Uh, he gave two valencies, primary and secondary.
Huh.
Then
Read this again once again
yeah.
and then tell me. Done?
Yes, sir.
Yeah, tell me.
What do I say it?
Yeah.
He in secondary, primary is ionizable and gives oxidation state.
In
While
coordination metal have two type of linkage or valency, primary and secondary.
sorry,
Correct?
sir.
Coordination metal have two type of valency. Coordination metal, according to Werner, right?
Yes, sir.
Yeah, that was the first one. Next.
Mm. The ions or groups are like bound by the
Hmm.
linkages.
Huh.
Secondary.
Correct.
Mm. The secondary valence is satisfied by neutral neutral ions or negative ions.
Huh.
Wait,
Primary
sorry, sir. Primary.
primary valency is satisfied by
Mm, I don't remember. Neutral
primary
atoms.
valency. No, 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 only negative.
Okay, only negative ions.
Huh. So uh, secondary valency is equal to the coordination number. And last, arrangement of the secondary valency can be different. This is the special arrangement, or also known as coordination polyhedra. Right? See, secondary valency have a characteristic special arrangement or 3D arrangement. Correct?
Mm. Mm.
This special arrangement is known as coordination polyhedra. You know, example, if there are four coordination number, so there are two possibilities. Molecule can be present in the tetrahedral form.
Mm.
Correct? You have a metal and molecule can be present in the tetrahedral form, or you have a metal and molecule have the square planar form. Right? Different
Mm.
arrangement of the molecule is present. Such arrangement is known as coordination polyhedra. Different form.
Okay, sir.
Right? So
Mm.
whatever is present within the square bracket is known as coordination entity or coordination complex within the square bracket. Outside counter ion. Example,
Mm.
you will call this whatever is the present inside this
Mm.
square bracket, it will be known as
Nation entity.
coordination entity, this part.
Mm.
Correct? And this chloride ion will be known as counter ion.
Counter.
Correct? He
Mm.
also said that there are different type of compound, different type of shape. Shape could be octahedral, X, tetrahedral, square planar if coordination number 4. These are the different geometrical shape. Correct? Example, here
Mm.
it will be octahedral. Why? Because there are 6 coordination number, right? 6
Mm.
ligand. Here again it will be 6. Here it will be 6. Correct?
Hmm.
In these two, it will be four. So two possibility are there. It could be tetrahedral or
Square.
squaroplanar that we will discuss in the later stage valence bond theory. Correct?
Hmm.
How to calculate this? Huh. This you asked question from this topic only, right?
Yeah, sir.
So on the basis of the observation, assign the secondary valency of the metal in this case. Example, if you have here moles of AgCl, remember this is AgCl mole. If two
Hmm.
AgCl are formed, what does it mean? Both the chlorine will be outside. Can I say this compound will look like this, right?
Hmm.
Only
Okay.
then it can form two AgCl.
Hmm.
Same here, two AgCl means two chlorine will be outside. How should I write it?
Nickel H2O 6 times and 2Cl out.
So what will be the secondary valency in case of first compound?
Is it
Four,
two?
because within the bracket there are four molecules. What is secondary valence in the
Okay.
second compound?
6.
Very good. Third case, no AgCl is formed means no chlorine will be outside. How should I write the formula?
Um, Cl4 Cl 2 times.
Correct? Because nothing is outside. That's why AgCl is zero, right?
Okay.
What will be
Okay.
the secondary valence in this case?
Um, will it be 8 or
Six. Six. How do I know? Four chlorine, two HCl, total six.
more chlorine fluoride? Okay.
What will be the secondary valence in this case? One chlorine will be outside.
Hmm.
Can I write like this? Correct? What is the
That's
secondary valence?
6.
Very good. Six. Last, no molecule is outside. What will be the secondary valency?
6. No, not 6. 4. Yeah.
Two ammonia, two chlorine, total four.
Hmm.
Easy to
Hmm.
understand.
Yeah, sir.
We all this are given. I think if you have to highlight, you were most confused in the third option.
Yes, sir.
Correct? How do I know this?
Yes.
Because no molecule is outside, everything is inside. That's why this is
Hmm. Hmm.
understood.
Yes, sir.
This pakka you will get question. Ki what is the difference between the double salt and complex compound? Okay. First, you have to tell what is the common. Both double salt and complex compound formed by the two or more stable compound in a specific ratio. Okay.
Hmm.
What is the difference? Double salt can dissociate into its simplest form when they dissolve in the water.
Hmm.
Double salt dissociate into simple ion when you dissolve in water.
Hmm.
How? Kernelite, KCl, MgCl2, 6s2. They will ask this question only. Kernelite. More salt, FeSO4 ammonium sulfate. This. After the class, you will write these three things five time. Okay.
So, can
Because
you
they will
repeat,
ask
sir?
after class, you will write kernelite,
Okay.
more salt, and potassium five
Potash.
time.
Okay, sir.
And then you will send me. Because potash element is easy. Potash means potassium
Hmm. Okay.
and alum means aluminium. So potassium and aluminium sulfate with
Mm.
12H2O. In remaining two, water
Okay.
amount is same 6,6.
Mm. Mm.
Okay. But if you see in case of complex compound, inside they do not dissociate. See these two compounds, they do not dissociate into Fe or Cn negative.
Mm.
Correct? This compound do not dissociate further into the simplest ion, but double salt can. Got it?
Yes, sir.
This is like very easy to understand. Not many questions asked from this. Whatever is the
Mm.
present inside the bracket is coordination entity. Okay. In this coordination entity, the metal part is known as central atom, like platinum, nickel, or iron,
Iron.
or cobalt. These are central atoms. Okay. And these are Lewis acid. What is the definition of Lewis acid? They accept electron.
So, it, huh, it,
Why? Because ligand donate electron.
huh.
Understood? Example ligand.
Yes, sir.
What are the ligand? Inside the coordination entity, whatever is attached to the central metal atom is known as ligand. Okay.
Mm.
It could be simple, like chlorine is very simple. It could be small, like water and ammonia is very small. It could be big, like this is in we will discuss. And it could be macromolecule, like protein could be also ligand. What is the role of ligand? Donate electron. Because they donate electrons, so they will be Lewis base.
Mm. Yes.
What are the meaning of the base? They donate electron.
Mm.
Got it? Example, chlorine
Yes, sir.
have negative charge, it can donate electron. Here, oxygen have lone pair, it can donate electron. Nitrogen have lone pair, it can donate electron. Right? Lewis base. This part is extremely important. We know ligand donate electron. Correct? If you are
Mm.
donating only one electron, then it is unidentate ligand.
Mm.
If you are donating two electron, didentate, like
Mm.
this and this. How? See here, in case of ethene, 1 to diamine, nitrogen have one lone pair of electron. This nitrogen also have one lone pair. So two nitrogen can donate electron. That's why
Mm.
didentate. Two donating side.
Mm.
In case of oxalate, what is the formula of oxalic acid?
C.
COOH, COOH. Okay. Same. From this oxalic acid, you form oxalate when you remove hydrogen ion. Got it? Now, this oxygen can donate electron, this oxygen can donate electron. Correct? So again,
Mm.
it is also didentate. Make sense?
Yes.
There could be many donor sites. Example, if you see here, this nitrogen can donate electron, and here you have three amine. These can also donate electron. That are polydentate. Make sense? Multiple donating
Mm.
site. Four. Example, very popular, ethylene diamine tetraacetate. This
Mm.
is hexadentate. How do you know? This is the formula of EDTA.
Mm.
Ethylene, two carbon ethylene.
Mm.
Correct? Diamine, two nitrogen.
Mm.
Tetraacetate, see, one, two, three, four. Four acetate group.
Mm.
So every this oxygen will donate electron to first oxygen, second oxygen, third oxygen, four donating site here. fifth this, and this is sixth. Make sense? Don't hesitate
Yes.
if you feel, ki, sir, I'm not able to understand. Four oxygen and two nitrogen
Yes,
total.
sir. Sure.
Okay, so total
Mm,
six donor sites are present here in this situation. Okay.
mm,
Next part is extremely important. Whenever you have didentate ligand or polydentate ligand, it should be minimum two. Okay.
mm,
So you know there are two or more donor sites.
mm,
They can simultaneously bind to the single metal. That is known as chelating ligand.
mm.
They will
Okay.
form chelating complex. This complex are more stable compared to the other compound. Tell me, sir, I did not understand anything.
Sir, I understood it.
Little bit. It is saying, example, you have this oxalate, didentate ligand because two donor site, two oxygen, correct?
Mm, yeah.
If this oxalate donate its electron to the same metal atom, what will happen? They will form a ring-like structure. It is saying if this ring-like structure is highly stable, more stable.
Mm,
Now makes sense?
yes.
You know, ring tend to be more stable because
Mm,
two or more sites are donating to the same atom.
mm,
Make sense?
yes.
So if you have more donor site and they donate to the same metal, they will form a ring. Ring are more stable. Such compound are known as chile ligand. They are ligand and they are chelate.
Mm,
Okay. Why they
okay.
form chelate complex? Chelate means when multiple things donate to the single atom. Any
Okay.
doubt?
No, sir.
Now you understood well.
Mm,
Last part. Sometime what happen? You have two different sites to donate from the same point. Example, you have to pay your fees to your school
mm,
institution. So your mother can donate money, your father can. Both of them can, right?
yeah.
But only one will donate at a time. It's not like both of them will do.
Mm,
Exactly same thing happen in case of ambidentate ligand. A ligand in which there are two different donor atoms, but only one will donate. Either of two ligand in the complex is ambidentate. Example, here you can see in NO2 nitrogen can donate atom to the metal or oxygen can
mm,
donate to. Compound name is exactly same, but donor site is different. It could be nitrogen or oxygen, same like mother or father,
okay.
nitrito and nitrito. Same situation here. Sulfur can donate its electron or nitrogen can donate its electron. Thiocyanato S or thiocyanato N. Got it?
Yes, sir.
Is it easy to understand?
Mm,
So two, three important things: denticity, number of donor site, chelate, formation of ring, ambidentate, many atom can donate, but only one will donate at a time.
okay.
Understood? Three important stuff.
Okay.
Now you can understand what is the coordination number. Number of ligand donor atom attached to the metal. Here it will be 6 because 6 chlorine. Here 4 because 4 ammonia. Right?
Mm, mm,
But you have to count denticity also. Example. In this case, what will be the coordination number?
18.
6. Why? This is oxalate, and oxalate is didentate. So it have two donor sides. One oxalate will donate two atom. So three oxalate will donate six. Understood? Three twos are six.
Okay.
Three oxalate will donate total six. So coordination number will be. I discussed this already, right? In is again didentate. In is again didentate. And you have
Yeah.
total three in. So what will be the coordination number?
6.
Exactly. Now look easy.
Mm,
Why?
mm,
Because oxalate is didentate, in is didentate.
mm.
What is coordination sphere? Same coordination entity. Same coordination entity.
Mm,
Central metal plus ligand together. See, this
mm,
is coordination sphere. This is coordination sphere. Outer is the counter ion. Coordination polyhedron arrangement. Arrangement of the ligand around the central metal atom. Okay. Here arrangement is octahedral
okay.
because 6, 4 tetrahedral, 4 in different ways, square planar like this. These all are polyhedron means arrangement, 3D arrangement. Any doubts,
Mm,
Farah?
no. Got it. So, what is the difference between like, coordination sphere and coordination entity? It's the same thing.
Exactly same. Very good. Keep asking question like that. Both
Okay.
are same thing because this is a good question. People confuse it, so that's why I will write here. This is also known as coordination entity. Any doubt?
No, sir.
You know the simplest way to calculate the coordination number of the. Okay, it is the charge
Mm,
if you remove all the ligand. Example in this case, it's how to calculate same like redox chapter. You want to calculate for copper, consider it X. You have four cyanide, each cyanide have charge -1, right?
mm,
Equal to -3 outer whatever is written
mm,
here.
yes.
So -4 will go to other side, it will become +4.
Mm,
So what is the oxidation number?
what?
What?
So,
Okay. Same thing you can calculate here also. For iron, I'm calculating X. 6 cyanide.
-1.
Correct.
Yes. Mm,
Last, very popular, though very easy, still it is popular because student can't correlate with the name. If you
mm,
have only one type of ligand, like only ammonia, only water, only chloride, such are known as homoleptic. Only one kind of ligand.
mm.
If you have different kind of donor, then it will be known as heteroleptic.
Hydrolytic.
Understood? Hetero means different type of ligand. Homo means same
Mm,
type. So now tell me, we did this for almost 40 minutes. How much time you took to cover the same content?
mm. Ah,
Approx.
around more than an hour, sir.
More than an hour. And like, were you confident like what you are now?
Yeah. No, like I kept forgetting everything, sir. I don't know why.
Because see, if you read by yourself, this is what happened. But when other person explain in easy language,
Mm,
then you will understand ki what are the keyword. You are
mm,
not supposed to read each and every word.
mm,
You need to focus on the keyword. Example here, if I mark with the different color. What is the important thing? Homolaptic heterolaptic is important. Oxidation number is not important. Polyhedron is
Mm.
not so popular.
Yeah.
This like how to calculate coordination number, especially when you have didentate or other ligand is important. These
Oh.
word ambidentate ligand, chelating
Mm.
complex, denticity are
Mm.
extremely important. Extremely. Example of polydentate like adata have six
Mm.
or ethane 1 to diamine or oxalate R2 are really important. Okay. Ligand are Lewis base and uh, central metal are Lewis acid is okay
Mm.
important. 100%
Mm.
you will get question from this double salt. 100%.
Okay, sir.
Kernelite, mohor and potassium. Kernelite, mohor and potassium.
Mm.
This is again for long question really important and question can be asked direct. Key
Okay.
write all
Okay.
different postulate of the Werner theory.
Mm.
Okay.
Okay, sir.
Then example in case of chlorophyll, we have magnesium.
Mm.
In case of cobalt, we have in case of vitamin B12, cobalt.
Mm.
Hemoglobin,
Iron.
iron, two positive. But nothing can be asked out of this. You will see tomorrow.
Okay, sir.
Now it look easy.
Yes, sir.
And even for this and this salt, what you have to do is write again and again kernelite. So calcium chloride, magnesium chloride, and 6H2. Then mohor
Mm.
salt, iron sulfate, ammonium sulfate, and 6H2O. Potassium is easy because based on the name you can understand key potassium and aluminium.
Mm. Yes.
Correct. Correct.
Mm.
So here you have to revise multiple times to get more clarity.
Okay, sir.
Otherwise, everything will be done. IUPSC you will definitely get when you have exam tomorrow.
Oh, so chemistry, right?
No, no, no. Tomorrow's exam,
Tomorrow's exam will begin at 11:30, sir.
11. And what is the distance of your room and exam hall?
Sorry, sir.
What is the distance of exam hall and your room?
Uh, Sir, it's like a few. Just I'll reach there by 1 minute, sir.
Just 1 minute. Okay, so if possible,
Yeah.
then tomorrow I'll try to take in the morning for
Okay, sir.
next half an hour. Sit and make short notes of this what I taught. Okay,
Okay, sir.
send me. After that, do physics and your exam portion. Nothing else.
Okay, sir.
Okay, and then again I'll take one morning class. So it will be just
So
a kind of yes,
tomorrow's batches of chemistry.
yeah, in the morning.
Okay, so you're going to continue this?
Yeah, this part.
Okay, okay, sir.
So I want to understand ki if I teach one chapter, how do you perform in exam?
Mm.
But at the
Mm.
same time, physics and tomorrow physics and biology, na?
Yes, sir.
Yeah, physics, biology important. So just maximum half an hour for this short notes. Then
Okay, sir.
focus on your physics and biology for the
Okay,
night.
sir.
Okay. See you
Okay,
tomorrow morning.
sir. See you, sir. Thank you, sir.
Okay.